Hello everyone, today we are going to explore the concept of pressure in liquids. Pressure is a fundamental concept in physics that plays a crucial role in many real-world applications. In this video, we are going to talk about the definition of pressure, types of pressure, instruments for measuring pressure, Pascal's law, applications, factors affecting pressure and some calculations.
Definition of pressure. Pressure is defined as the force exerted per unit area on an object or a surface. In the context of liquids, pressure is the force exerted by liquid on the walls of its container or object it submerges it in. So pressure can be in different forms. It can be in liquid, it can be on air, it can be on anything. Now we're moving on to the types of pressure in liquids. Type of pressure in liquids include hydrostatic pressure, dynamic pressure, gauge pressure. When we're talking about hydrostatic pressure, the pressure exerted by a liquid at equilibrium due to its weight. Dynamic, the pressure exerted by a liquid in motion.
Instruments used in measuring pressure: piezometer, manometer, diaphragm pressure gauge, barometer, micromanometer. Pressure gauge: these instruments rely on Pascal's law to accurately measure fluid pressure within systems by tapping into the principles of pressure transmission. Pressure gauge provide crucial insight into fluid dynamics in various industrial and scientific settings. Manometer: it is applied to one end of the manometer tube, and the unknown pressure to be determined is applied to the other end. Pascal's law states that pressures applied to an enclosed fluid will be transmitted without a change in magnitude to every point of the fluid and to the walls of the container.
Applications of atmospheric and gas pressure. They include the siphon, the syringe, bicycle pump, lift pump, and the force pump. Talking about the syringe is a device that consists of a piston which fits tightly into a cylinder. The cylinder has a nozzle at one end. So when the nozzle is dipped into a liquid and the piston is pulled up, because of atmospheric pressure, it pushes the liquid up in the cylinder. The same process goes when the piston is pressed downward. Factors affecting pressure: we have depth, density, and gravity. Talking about depth, the pressure increases when the weight of an object is more. Example, diving into a pool. Pressure is directly proportional to the density of a liquid. Example, a sharp knife and a blunt knife. Talking about gravity, pressure is affected by acceleration due to gravity, e.g., an apple falling from a tree.
Now, the SI units of pressure includes Pascal, Newton per meter square, millimeter mercury. Moving on to the first problem. A container filled with water has a height of 10 meters. If the density of water is 1000 kg per meter cube, what is the pressure at the bottom of the container? So now the formula for pressure in liquid is density times acceleration due to gravity times height. So with this, you can easily solve basic questions on pressure. So the density given to us here is 1000 kilogram per meter cube, and the gravity is 9.8 meter per second squared. Then the height is 10 meter. So multiply everything, you get 98,000 Pascal. We also apply the same formula to this question. We just place in our parameters and then we get our answer. Thank you so much for watching. See you next time.